Hello, colleagues. My name is Professor Woodcock. Today, we're exploring a major advance in sustainable respiratory care through the development of a low-carbon salbutamol pressurized metered-dose inhaler, or PMDI. This innovation is a key step to maintain future access to inhaled treatments for patients with asthma and COPD, while significantly reducing the environmental footprint. This study was funded by GSK. The study ID is 223743. I have received speaker fees from GSK, but not any payment for this video. I'm a member of the Montreal Protocol Medical and Chemical Technical Options Committee, but these are my own personal views. The full disclosures of my co-authors can be found on this slide. Climate change is a growing threat to global health, and healthcare itself contributes to about 5% of worldwide greenhouse gas emissions. PMDIs are a substantial part of this, due to their use of hydrofluoroalkane or HFA propellants. These are also known as HFCs. Salbutamol PMDIs are the most widely prescribed reliever inhalers globally, making their environmental impact especially important. We ran a full life cycle analysis, cradle to grave, comparing three types of salbutamol inhalers: a PMDI with HFA 134A, a new PMDI with a low global warming potential propellant, HFA 152A, which is in clinical development, versus a dry powder inhaler, or DPI. The carbon footprints were calculated using data from 7 countries and over 2,000 data points, and our findings were independently verified by the Carbon Trust. Across the 7 countries studied, the mean total carbon footprint per device was nearly 27 kilograms of CO2 equivalent for salbutamol PMDI with HFA 134A, compared with just 2 kilograms for salbutamol PMDI with HFA 152A. The change from the current HFA 134A to HFA 152A is predicted to reduce the inhaler's carbon footprint by about 92%. This is equivalent to reducing the emissions from a 192-kilometer car journey down to just 15 kilometers per inhaler, getting closer to that of a DPI. This means that the patients will be able to choose their preferred inhaler, PMDI or DPI, without the high carbon footprint of current PMDIs. The mean number of annual salbutamol inhalers prescribed for asthma across 5 European countries range from 1.6 to 4.2 inhalers. This change in propellant will mean that an individual patient will reduce their own mean annual carbon emissions by 39 to 104 kilograms of CO2 equivalent, which is equivalent to a 284 to 746 kilometer distance driven in a car. The number of GSK's salbutamol PMDIs across countries range from 1.16 to 12.58 million inhalers, with a carbon footprint in each country ranging from about 31,000 to over 330,000 tons of CO2. The replacement with HFA 152A propellant would reduce annual carbon emissions by hundreds of thousands of tons in CO2 in some countries. In summary, the next generation salbutamol PMDIs with HFA 152A, which are in clinical development, will allow patients to continue using a familiar device while reducing carbon emissions by an expected 92% compared with their current HFA 134A inhaler. The development of salbutamol PMDI with low GWP HFA 152A propellant will, along with DPIs, enable patients to choose their preferred inhaler without the high carbon footprint of current PMDIs. Thank you for listening.